Hi friends, this video is regarding the single phase off wave rectifier. I have done some numerical problems on it. Of course, one of the problems is from full wave rectifier also. So let's move forward. I will hardly take very less time to finish it off 5 problems. Okay, the first problem is single phase 230 volt 2 kilowatt heater is connected across single phase 230 volt 50 hertz supply through an SCR. For firing angle 60 degree, calculate the power absorbed in heating element. So it's very simple and it is easily understood that it is a off wave rectifier because we are the load or the heater is connected through an SCR, and it is clearly mentioned that it is a heater, so the load is R load. So with this clarity we can go ahead with the SCR, we can go ahead with the SCR, I mean half wave rectifier with R load. Okay, so the firing angle has already given, it is 60 degrees, so it is clearly mentioned that it is a single phase half wave rectifier with R load. So it's very easy now. So we can easily calculate the power absorbed in the heating element. So how to calculate power absorbed in the heating element? So what we have learnt in the electrical circuit analysis or network analysis, the power absorbed by the heating element or the power absorbed by the resistor is I square R or V square by R. So here the resistor is output, so V square by R means V naught square by R. So what is V naught square there? V naught means it is R, it should be an RMS value. Okay, it should be squared divided by resistance. So now our job is to identify the resistance and also V naught RMS. Very simple and very clear. So let's move forward. So resistance can be calculated by using the rating of the element. Okay, the rating of the element is 230 volt and 2 kilowatt. So V square by R, where 230 is the V and divided by 2 into 1000 is 2 kilowatt. So this is because of the rating of the heater. Okay, based on the rating of the heater, we need to find out the resistance. And once we get the resistance, that is 26.45 ohm, we need to go ahead with the calculation of V naught RMS. So this is RMS output voltage. So V naught RMS is equal to Vm by 2 root pi into pi minus alpha plus sine 2 alpha by 2 whole power 1 by 2. Okay, so this is the formula for V naught RMS. If you missed out my lessons, I have already uploaded one video based on how to find out the RMS output voltage and average output voltage for the single phase off wave rectifier. You just go and check it once. Okay, so this is the formula. Once we substitute all the values, so substitution is very important. So wherever pi element is there, you have to substitute alpha in terms of pi. Wherever simple element is there, you need to substitute in terms of degree or radian. And coming to your calculator, so based on your calculator setting, if you put the value in degree mode, then you have to apply degree only. So I put my calculator in degree mode, so I have written 120 degree here. Otherwise I would have written 2 pi by 3. Understood? If I put my calculator in radian mode, then I need to put here, instead of 120 degree, I need to substitute 2 pi by 3. Understood? So this nomenclature you have to mention, but here you should definitely mention pi by 3 only instead of alpha, because it should be subtracted from pi. So this is in radians, and once you get some value in pi means 3.14, you have to substitute 3.14 only, but not 180 degree. Okay, please remember these points. These points are very important points. So the final answer will be 1.145.87 volt. So this is our V naught RMS. So simply now our job is to identify the power absorbed, that is V square by R. R has been obtained, V naught square has been obtained, so you can easily find it out. So power absorbed by heating element for alpha equal to 60 degree is this one, V naught square by R. V naught square is 145.87 whole square divided by 26.45. So it will come around 804.46 watt. Okay, so this is the first problem. So let's move on to the second problem. So second problem is a 230 volt 50 hertz 1 pulse SCR controlled converter is triggered at a firing angle of 40 degree and load current extinguishes at an angle of 210 degree. Find circuit turn off time, average output voltage and average load current for R is equal to 5 ohm and L is equal to 2 millihenry. So this is the problem. So let's move forward. So it's very simple. You can easily understand here. It's a one pulse SCR. So that means it is a half wave rectifier, and firing angle is 40 degree and the current extinguishes at angle of 210 degree. That means it is beta extinction angle. So when extinction angle will come, definitely if the load is RL load. Simply we can go ahead with the circuit turn off time. So if the load is RL load, the circuit, the thyristor is in reverse bias from 2 pi minus beta divided by omega. So that will be the our circuit turn off time, and average output voltage is as usual with RL load, whatever formula is there you need to use that, and average load current, obviously it is load current means current is equal to voltage by resistance only. So you can simply do it, very simple. Let's move forward. Simply circuit turn off time is 2 pi minus beta whole divided by omega. Beta is 210 degree, so it should be converted into pi, so it is around 7 pi by 6. So substitute that, so you will get 8.33 millisecond. So this is the circuit turn off time. So let's move forward to identify average output voltage. So average output voltage formula is V naught is equal to Vm by 2 pi into cos alpha minus cos beta. Same thing, this part I have already explained. You can go back and check my videos. So the value will be 84.489 volt. So load current will be V naught by R, simply 84.489 divided by R is given as 5 ohm only. So divided by 5. So it will come around 16.8978. Very simple concept. Now let's move on to the third problem. So the third problem is like this: a single phase transformer with secondary voltage of 230 volt 50 hertz delivers power to load R equal to 10 ohm through a half wave rectifier, control rectifier. Now for a firing angle delay of 60 degree, determine rectification efficiency, form factor, voltage ripple factor, transformer utilization factor and peak inverse voltage of the thyristor. So for these type of problems, you have to first mention the formula. After that, you have to do the problem. After that, you have to solve the, you have to get the value. Okay, for these three, you will get 3 marks. This is the scheme of solution for generally people who go ahead. Okay, for formula, 1 mark will be given. For solution, for procedure, you will get 1 mark, and for value you will get 1 more mark. So 3 marks for each bit. Okay, so let's move forward. So rectification efficiency means it is rectification efficiency. So output power by input power means output is DC, input is AC. DC means V naught average into I naught average. AC means V naught RMS and I naught RMS. So find out average V naught I average and I naught average and multiply them, you will get PDC. Simple. Next one, V naught, find out V naught RMS, I naught RMS, multiply them, you will get PAC. Very simple. Next one, rectification efficiency formula is PDC by PAC. So you know PDC, it is 602.98 watt. You know PAC, it is 2127.89 watt. So divide 1 by 1 so that you will get 0.2834. If you want to get percentage efficiency, it will be 28.34%. Simple. So now what is form factor? So form factor is V naught RMS by V naught. So it will be equal to 145.873 divided by 77.65. Okay, so it will be equal to 1.878. So this is the form factor. Now coming to voltage ripple factor, VRF is equal to square root of FF square minus 1 is the formula. FF means form factor. So form factor square root of 1.878 whole square minus 1. It will come around 1.5903. Coming to transformer utilization factor, so it will be equal to output by input. So transformer secondary output is V naught I naught divided by input is VSIS. Okay, so that we have to ascertain. So IS means it is same as I naught in the form of RMS. Okay, so you have to take IS is equal to I naught RMS, VS equal to VS, that was already mentioned there, that is 230 volt. So simply you will get 0.1797. So peak inverse voltage equal to Vm only, so it will be equal to square root of root 2 into Vs. Simple. 325.27 volt. So very simple problem. Please understand how to solve it and do it. So the next problem will be a single phase off wave rectifier is operated from 120 volt 50 Hz supply. Load resistance R is equal to 10 ohm. If the average output voltage is 42.43 volt, determine firing angle, RMS output current and average output current. He wants currents, okay, and firing angle also. He has already given you output, average output voltage. So write the formula for average output voltage, substitute whatever given, and finally you will left with only alpha. Find out alpha, then you can go ahead with the RMS output voltage and then RMS output current. You have already given average output voltage, so with that you can easily find average output current. Very simple problem. Yeah, so this is the formula for half wave rectifier, Vm by 2 pi into 1 plus cos alpha. So after calculation we are getting alpha equal to 55.19 degree, and RMS voltage is formula is this one, and after that if you substitute you will get 38.358, and RMS current is V naught RMS by R simply, so it will be equal to 3.8358 ampere. Now the average output current is V naught average divided by R here. Okay, so actually I have taken the value of average only, but I have written it wrongly. It is V naught RMS, so it's not RMS, it is average. So V naught average is 42.43, it was already given, divided by 10 is equal to 4.243 ampere. Now the fifth one is this is the full wave rectifier. So a highly inductive DC load requires 12 ampere at 150 volt from a 230 volt or single phase AC supply. Give design details for this requirement using M2 connection and B2 connection for alpha equal to 30 degree. Assume each SCR to have a voltage drop of 1.5 volt and compare the two designs. So this is very important and nice problem. So it explains the complete operation of full wave rectifier, midpoint connection and also bridge connection. So M2 connection means midpoint connection, B2 connection is bridge connection. So what is the difference between these two? So those things were nicely explained by using the design details. So what does it mean by design details? Design details means we have to go ahead with transformer rating and circuit converter rating, everything. We will see how nicely it was explained. For M2 connection, let's go ahead with V naught average. So V naught average is equal to 2 Vm by pi cos alpha. And here V naught average is equal to 2 Vm by pi cos alpha minus 1.5, because 1.5 drop is there. So it is midpoint connection. So for one off cycle, only one thyristor is conducting. So it is giving that much drop only, that is 1.5 volt. So V naught average is equal to 2 Vm by pi cos alpha minus 1.5. Very simple. So now V naught average has been given as 150 volt. So now find out Vm. So Vm will be equal to 274.8 volt. So once you get the Vm, hence each section of transformer secondary requires RMS voltage of Vrms is equal to 274.8 divided by root 2. So this is maximum value. So that is RMS value. So each transformer secondary requires 194.31 volt. Okay. Then what is RMS current? It should be divide. Current has been given as 12 ampere. So that is maximum current, and the RMS current will be 12 by root 2 is 8.49 ampere. So these are the ratings of transformer secondary. Therefore, transformer secondary rating is 2 VI, that is 2 into 194.31 into 8.49. Why? Because it is whatever we are discussing now is for one off cycle. For the second off cycle, it should be one more. And what is the transformer output? It should be doubled. Okay, we have already discussed VAN and VBN. So it will be VAB. Okay, we are discussing only VAN here, so it should be doubled. Okay, so it is 2 VI, so 2 into 194.31 into 8.49, all are RMS voltage. Okay, RMS voltage and RMS current. So the kVA rating required for the transformer is 3.3 kVA. So the transformer voltage rating is 230 by 194.31, because 230 is at the primary side, 194.31 is at secondary side. So transformer primary current is in RMS value. It should be like this: 12 into 194.31 by 230, which is equal to 10.14 ampere. This might be studied in your transformers class. Okay, V1, I mean V1 by V2 is equal to I2 by I1. Understood? So based on that, it has come. So coming to peak inverse voltage, it is 2 Vm. This part also we have already seen. So in midpoint connection, the peak inverse voltage is 2 Vm. It is equal to 550 volt. So IRMS, of course, it was already covered. So forget about this. These are the ratings of M2 connection. Ratings means what is the kVA rating of the transformer. So what is the voltage rating of the transformer. I mean turns ratio, voltage ratio. Okay, now let's move on to the bridge connection. So for bridge connection, same, we have to go ahead, but here what happened means, here two thyristors are conducting in each off cycle, so the drop is 3 volt, 1.5 plus 1.5. So Vm will be equal to 277.52. So the transformer secondary voltage will become 196.24, and this current secondary current is 12 ampere only. Okay, it is a square wave, so it is, we are getting 12 ampere. So transformer secondary rating will be Vi. Here the rating is Vi, not 2 Va. So 2.35 kVA is sufficient for us. Okay, so the transformer voltage ratio is 230 by 196.24. Transformer RMS primary current will be 12 into 196.34 by 230. It will come around 10.24 ampere. For each SCR, peak inverse voltage is Vm is equal to 277.52 volt. So IRMS is 12 by root 2. It is 8.49 ampere. So this is the regarding bridge connection. So previous thing is regarding the midpoint connection. So finally we can conclude the SCR lost. So what is the voltage drop at the SCR in first connection is 1.5 volt divided by 150. It is 1% of the load power. 1% of the load power. So coming to SCR loss in the second bridge connection, here two thyristors are conducting in each off cycle. So we are losing twice the voltage drop, that is 3 divided by 150. So it is a 2% of the load power. And comparing the two circuits A and B, B2 connection is superior in transformer size, because in M2 connection transformer size is more, in B2 connection transformer size is less. So with less transformer size we can go ahead, so that cost will be reduced, weight will be reduced, and space may be reduced. Everything will be reduced. Okay. And SCR voltage rating requirement, yeah, even voltage rating also very less compared to previous case. But what is inferior? So the inferior in SCR loss. Why? Because in B2 connection we are using two thyristors for one off cycle of operation. In M2 connection we are using one thyristor for one operation of off cycle operation. Okay, so these are the different cases, the basic difference between M2 connection and B2 connection. The problem was very nice problem. Okay, please go through it and get the more knowledge on it. So if you have any more doubts, please put it in the comment window so that I can reply you within 24 hours. So thank you so much for your careful listening. Please like my video if you like it, and please share this video with your friends and family, and kindly subscribe to my YouTube channel. Thank you so much.